All right, good morning. Day 8. Hopefully, I don't struggle as much as I did with day 7. Learned some lessons about string parsing. If you haven't seen that, go check it out. Some good lessons at the beginning of the video. All right, let's get started. All right, your flight to the major airline hub reaches cruising altitude without incident. While you consider checking the in-flight menu for one of those drinks that come with a little umbrella, you're interrupted by the kid sitting next to you. Their handheld game console won't turn on. They ask you if you take a look at it. You narrow the problem down to a strange infinite loop in the boot code, which is your puzzle input. You should be able to fix it, but first you need to be able to run the code in isolation. The boot code is represented as a text file with one instruction per line of text. Each instruction consists of an operation, ACC, jump, or nop, and an argument, a signed number like +4 - 20. ACC increases or decreases a single global value called the accumulator by the given value in the argument. For example, ACC +7 would increase the accumulator by 7. The accumulator starts at 0. After an ACC instruction, the instruction immediately below it is executed next. Jump jumps to a new instruction relative to itself. The next instruction to execute is found using the argument as an offset, and no op. It does nothing. The instruction immediately below it is executed. Okay, so, I forgot. Let's make a new file really quick. I was going to jump right in, but in case you can't tell by how dark it is, recording a little bit earlier than usual, but I've been a little all over the place, so I guess it's not that surprising that we're a little bit off schedule. File private, put and then let's change the main to call day 8. Cool. Okay, so we're going to jump right in here. This is for those of you that don't recognize it. This is more or less just machine code. So these are like the type of instructions you would see on like a chip or something really low level. And so all we're going to do is we're going to parse this. So ironically, we probably don't need to use a regex on this, but I kind of want to just to practice. So we're going to do that regex 101. So I think what I want here for my regex is going to be pretty straightforward. So let's paste this in here really quick. And so I think what I want is first group is going to be A through Z and any number of them. And then a space. Let's see, 0 and 1 times as many times as possible, given back as needed. A through Z, and then I think I need to wrap this. So this is where I don't know regex capture group syntax very good. There's a problem in it. Oh, there's left to right. Character class, missing closing bracket. Plus or minus, and then a digit. Do I need to like escape that? Okay, so I think these are two separate capture groups. Let's see. Okay, so that's okay, so that's fine for capture group 1 there. So I'm gonna save that, and then the next part is regex a single character in set. Let's see, character classes and character sets. Let's see, matching closing bracket X matches a character. Let's see, to match any single character. Yeah, I guess I could do that. That's kind of not what I want. If you want to match a single character, put it inside those brackets. Okay, so if I do bracket plus or minus, and then /d plus, and then wrap that as a capture group. Okay. I'm doing the capture group thing because that's how I wrote my extension, is to rely on capture groups, when I could just have left off the parentheses and made it the full match. Okay. So what we're going to do is we're going to have an operation. So operation. An operation has actually we can have the instruction. Instruction is going to be an instruction. I'll define that in a second, and then the jump will be an integer. It looks like they're decently controlled. They're not throwing us anything crazy. And then an instruction is no op, which is op. String a no op. Accumulate, which is ACC. Is it equals? Equals what it is, and then case jump equals JMP, and then init from a string. And this is where we're going to do the regex thing. What did I call it? Matches. Okay, so self dot jump equals int string dot matches for this part right here. Hashtag that. Try that. Matches dot first. And then type of it. Dot first, dot first, yeah, because I wrapped it. Okay, yeah, ugly. Again, that's why I would not use my little extension elsewhere, because it's a little ugly, but it is so much faster than what I was doing before. So self.instruction equals an instruction from a raw value, which will be try string.matches dot first. I guess I could do something with my extension to make that a little nicer. Okay, and then we're going to map these into operations. Operation from string $0. Okay, so that will give us our lines. And so what is our output? The instructions are visited in this order. Does nothing when the accumulator is increased from 0 to 1, blah, blah, blah. Okay. This is an infinite loop. With this sequence of jumps, the program will run forever. The moment the program tries to run any instruction a second time, you know it will never terminate. Immediately before the program would run an instruction a second time, the value of the accumulator is 5. Before the program would run an instruction a second time. Run your copy of the boot code immediately before any instruction is executed a second time. What value is the accumulator? Okay. Okay, so basically what we want to do is we're going to run these top to bottom, and then so what we'll need is we'll need an index, which will start at 0. We need accumulator, which is also an int, and it starts at 0. And then, so while index is less than or equal to lines.count, and then we're gonna say history is a set of integers. I think, okay, so there's actually probably a smarter way to keep track of history, but I think that's easy enough. And then we're just going to say, if history.contains index, then we're going to break. So that'll be our short circuit. So when we hit an instruction twice, and then otherwise, we're going to do we're going to get let operation equals lines of index. So we're going to get the operation that is next in line. So start from the top, running all the way to the bottom, unless we're told to jump. And then what we're going to do is we're going to say, so that gets the operation, and then we're going to switch on operation dot instruction, and it should complain and give us an autocomplete. I think there's like a keyboard shortcut to actually do that. I don't know what it is. I should figure that out. So if it's a no op, we're going to do nothing. If it's accumulate, we're going to do accumulator plus equals the operation dot, I called it the jump, and now I'm realizing that's not correct. And then otherwise, we're going to do index plus equals the jump. And then what is it? What do we do? Is no op always plus 0? Okay, does nothing. Then the accumulator increased from 0 to 1, and jump plus 4 sets the instruction. Yeah. So this would be 2, and that changes it to 6. So 0, 1, 2, 3, 4, 5, 6. Yep. Okay. So this looks pretty easy. And then we're going to history.insert. Yeah, index. And then we're going to print accumulator. Okay. Hopefully that's part 1, or that's not part 1, but that's gives us the right answer for ooh, interesting. Unwrapping an optional. Nop plus 0. Nop plus 0 did not match that. Oh, nop did not match this part. Really? Did I spell not wrong? Is this like literally the very first thing is failing? Like, do we make it through any of these? Okay, so like the very, very first one. Is it upset because I called it no op? and I'm doing I wanted it called no-op. No, it still isn't fun. Actually, let's undo the no-op changes, and then let's try this again, just so I can see what I'm doing wrong. Oh, crap. Okay, it's matching. It was matching individual letters, I bet, huh? Yeah, okay. So we need the plus in there. This is why we are learning. Okay, cool. So now that that is working, put that back in there. Okay, program ended with 0. Is that right? Forever, the moment the program tries to write an instruction. So immediately before the program would run an instruction, a second time the value of the accumulator is 5. Okay, let's follow along and make sure that our thing is jumping around correctly. Oh, done. Yep. Index plus equals 1, and then index plus equals 1. Let's see if that actually fixes it. Nope, still doesn't fix it. Okay. Operation. The operation is not showing up. Why is it not showing up? Could not find operation in scope. Okay. Okay, it's the no-op. History inserts the index. What? Oh, duh. It needs to go right here before I do it. Just out of order. Okay. Operation. No op index plus 1. Yep. And now it is accumulate. Let's follow along, make sure you're doing it right. Yep, accumulate. So plus 1. Okay. Jump. Index goes from 2 to 6. Yep, looking good. Okay, this looks like it's doing everything right. And ends on 5. Okay. Let's try their giant program that they've written for us and see how it runs. So if you haven't been watching the other videos, this is one of the tips that I give if you want to avoid a headache for yourself, is make sure you get their sample input working real good very first thing, because it is so much easier to debug their sample input. There's a text talking about the new AirPods Max and their $550 price tag. After some careful analysis, you believe that exactly one instruction is corrupted. Somewhere in the program, either a jump is supposed to be a no-op, or a no-op is supposed to be jump. No accumulated instructions were harmed in the corruption of this boot code. The program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. By changing exactly one jump to a no-op, you can repair the boot code and make it terminate correctly. For example, considering the same program before, if you change the first instruction from no-op 0 to jump 0, it would create a single instruction infinite loop, never leaving that instruction. If you change almost any of the jump instructions, the program will still eventually find another jump instruction and loop forever. However, if you change the second to last instruction from jump -4 to no op -4, the program terminates. The instructions are visited in this order. After the last instruction, accumulate +6, the program terminates by attempting to run the instruction below the last instruction in the file. With this change, after the program terminates, the accumulator contains the value 8. Okay. Fix the program so that it terminates normally by changing exactly one jump to a no-op or no-op to a jump. What is the value of the accumulator after the program terminates? Oh, okay. So what I'm going to do, and this is going to be an array of operation. And it's going to return the value if it succeeds. It's going to return the accumulator and whether it hit an infinite loop. Okay. So what we're going to do is we're going to put that here. So part 1 would be, part 1 is run program lines, and then, result is, let's see, this is going to be accumulator and finished, and then we're going to print accumulator finished. So that's part 1. Okay. Return, and then it's going to return accumulator and whether index is greater than or equal to lines.count. This is supposed to be less than, just less than. Okay. So we should, if we just run it again with the part 1 input, we should get 1528 false, because it, yeah, okay, perfect. So then what we're going to do here is we're going to we're going to go through and we're going to change we're going to try every single jump and no op. Okay, so in 0 less than lines.count. So I'm just going to go through all of them, I guess. And then, because we know that, we already know from the beginning that it's not working. So, yeah. Let operation equals lines dot lines sub I. And then what we're going to do is if operation if line sub that was talking and typing code. If operation equals dot I want to switch, not an if. Jeez. In fact, I want this switch. Faster than typing. Okay. Okay, if the instruction is a no op, then what we want to do is we're going to do let copy or var copy equals operation equals lines, and then we're going to say copy dot remove. Is there a replace? No. Remove at I, and then copy dot insert at I, and this is a no op, so we're going to replace it with a jump. Actually, I think if I put this in in an extension, I'll get the initializer for free. The memberwise initializer. Okay, is it still happy? No, it's not. Extension on operation. Okay. Okay. This is going to be a new operation. Perfect, with a jump, and it is operation dot jump. I should not have named that jump. Okay, and then we're going to have let to run is an array of operations. Has no member J, maybe just not recompiled. Okay, and then to run equals copy. Okay, and then yep, we're not going to do any of that. Okay, continue. So we're not doing anything if it's an accumulate, and then no op. Okay. Okay, and then what we're going to do is we're going to say literally this, except for this is going to be to run, and this is going to be let finished, if finished, then break, but we're also going to print accumulator. Is that what it wants? What's the input? Fix the program so that it terminates normally by changing exactly one jump to an op or one op to a jump. What is the value of the accumulator after the program terminates? Okay. Okay, if you change the first instruction, however, if you change the second to last. Okay, let's try this really quick with their input and see if it does what they say. And it finished. Last instruction, the accumulator contains the value 8. Okay, it says that worked. So first one is 1528 false and 640. Let's try. 1 gold star. Hey, not too shabby. Okay, so let's review really quick for things that we may have learned. First of all, I'm loving this extension because then I don't have to, it gives me a result that's an array of strings, which is awesome. I don't want to change the substring type back into strings, so that saves me a step, which is awesome. This extension right here, even though it is ugly and full of force unwraps, is so much simpler. We made this last episode, so check that out if you want to actually see that being made and what caused that to be made. And yeah, besides that, like running the instructions is actually, I think, pretty straightforward. You're literally just keeping track of where you're at in a list, so starting at 0 and going down, and jumping around based on what the instruction is. And the only thing you have to be aware of, the input is such that you don't have to worry about it being greater than or equal to 0, but you could also, you could do that, right? Like if this was unvalidated input. So pretty easy to just go through the list of instructions and just pick the one to do the operation that it wants done. So pretty nice, pretty easy challenge for the for the 8th day. Much faster than last time. Okay. Thanks for watching. If you're enjoying these videos, if you're enjoying watching me learn, or if you're learning yourself, make sure you like and subscribe so you don't miss them. And it also helps out the videos a ton. Lots of people discover it because of the liking and subscribing. It just helps the algorithm. We'll catch you tomorrow, and we'll catch you for the next 17 days. So look forward to seeing you then. Okay, bye.